Didn't see you there. Welcome to another episode of Sloan Physics. Today we'll be talking about collisions.
So what are collisions? There are two types of collisions, elastic and inelastic. Elastic collisions are where momentum and energy are conserved, and inelastic collisions are where only momentum is conserved and energy is not, and energy is lost through other forms such as heat, friction, and sound.
So there's one more type of collision. It's called the perfectly inelastic collision. In this collision, it's the same as inelastic, however, maximum kinetic energy is lost.
That's embarrassing. Well, to show you how to differentiate between the three collisions, we designed an experiment for each one and calculated what type of collision it was.
Oh, sorry for interrupting you. Before we get started, we first need to teach you how to calculate momentum and kinetic energy.
The equation to calculate momentum goes as follows. P equals to mv, where P is the momentum, m is the mass of the object, and v is the velocity of the object. When calculating the total momentum, remember, momentum is a vector, which means it has direction. Make sure to account for positives and negatives when adding up all momentum.
The equation to calculate kinetic energy is K equals 1/2 mv squared, where m is the mass of the object and v is the velocity of the object and k is the kinetic energy.
Once again, remember to add up your total kinetic energies when calculating the individual energies of each cart.
Part of the experiment, we conducted multiple trials to simulate a perfectly inelastic collision.
As you can see, a specific trait of the perfectly inelastic collisions are the carts sticking together. This shows there was a loss in kinetic energy.
As visible from the data collected, there was quite a bit of energy loss in each collision. The momentum was almost consistent due to the law of conservation momentum. However, since there was an immense energy loss, this reveals that the collision was perfectly inelastic, as the definition states that there must be maximum energy loss.
In the next part of our experiment, we conducted multiple trials to simulate an elastic collision.
As you can see in these trials, the faster cart becomes the slower cart after the collision. Also, when both carts had the same velocity before, they had the same velocity after.
As you can see from the data, both the momentum and the energy throughout the trials are practically consistent. This shows that the collision was elastic.
In the last part of our experiment, we conducted multiple trials to simulate a regular inelastic collision.
In these trials, it is visible that the velocities before and after the collision are different. This shows that the kinetic energies are different due to loss of energy in the form of heat, sound, or friction.
As you can see in this collision, the momentum was conserved in all trials due to the law of conservation of momentum, but the energy was lost from the beginning to the end. The loss was not drastic enough to confirm that the collision was perfectly inelastic.
Thank you for joining us on another episode of Sloan Physics. We hope you can now calculate the momentum and kinetic energy of collisions and can also differentiate between them.